Okay, here's one last type of parametric equation you need to be aware of, which is ones that use trig functions. And we're trying to get the Cartesian equation once again. Now, sometimes these are show that questions, as we had in the previous video, but sometimes you just have to spot what you need to use. And in most cases, that's going to be an identity. So that's the place to start. So I've got x, and it happens to have cos theta in it. I've got y that happens to have sine theta in it. So I think, do I know an identity that's got cos theta and sine theta in it? And yes, I do. I know that sine squared theta plus cos squared theta equals 1. So the things that appear in the identity are sine theta and cos theta. So the next thing to ask myself is, can I make sine theta and cos theta the subject of these equations? So, cos theta can be got from x. Cos theta is x over a, and sine theta is y over b. So I'm rearranging to try and get the theta things that appear in my identity. And once I've got them, I can substitute them in. So this sine squared theta is going to be something squared, but sine theta I now know is y over b. And when I get to this cos squared theta, that's something squared again, but cos theta is x over a. So y over b squared plus x over a squared equals 1, and that is my Cartesian equation, and it's not really worth trying to substitute that. That's fine as it is. Okay, so that's a clue about the kind of thing we have to do here. I can see that x includes tan and y includes sec theta. So what links those? Well, you should know that sec squared of theta equals, what's the identity? Come on. Okay, you should have got written down that sec squared theta is 1 plus tan squared theta. Okay, you need to learn those. Okay, so I can make sec theta the subject of this. So sec theta equals y minus 1. This one is even nicer. I don't have to make tan the theta the subject. I can make tan squared theta the subject. Oh, it's just x. Because I need a tan squared theta here. So I don't need to rearrange any more than is necessary to get something usable out. So this bit here is going to be 1 plus, not x squared, it's just 1 plus x, because x is already tan squared. This sec squared theta is my y minus 1, that's sec theta, and I need to square it. So this is my Cartesian equation here. This one I think I will try and simplify, because if I multiply this out, remember squaring a bracket, you don't just square this and square this, you have to have the middle term, which is minus 2y plus 1 equals 1 plus x. So y squared minus 2y equals x. That'll do. That's simple enough for me. And just one more of these. Okay, so if you look at the trig bits, I've got a cos 2 theta and I've got a sine theta. Do I know a trig identity that links those? Well, cos 2 theta, I know several identities for that. Cos 2 theta, remember, there are 3 forms. There's the one with a mixture of cos and sine, there's the one with just cos squared, and there's the one with just sine theta, which is clearly the one I want, because I've got sine theta, but I haven't got cos theta. I know that y is sine theta. So cos 2 theta is, again, you're supposed to know this, it's 1 minus 2 sine squared theta. So cos 2 theta, okay, make cos 2 theta the subject. Cos 2 theta equals, take one away, x minus 1. Don't need to change anything here, because I just want to know what sine of theta is, not x. Okay, sine theta is just y. So this cos 2 theta, I now know is x minus 1, equals 1 minus 2 times something squared. What am I squaring? Sine of theta is just y. So x minus 1 equals 1 minus 2y squared. So I can say that x plus 2y squared, and add this one to both sides, equals 2. And there's my Cartesian equation. So these were all simple ones where you had to come up with the trig identity that you needed, and then you made the trig terms the subject of these equations so that you could substitute nicely into the trig identity. Hope that helps with these.